Hello. So I hope you are all having a lovely holiday. All right. So here we are. Let's start with how do you do the problems from chapter 6 using SAS? So here's our first problem. We have some data collected on coffee consumption among undergraduates, and here's our number of cups they drank every day. And what we need to do for this is compute the sample mean, compute the sample standard deviation, and construct a 95% confidence interval for the mean cup of coffee consumed among undergraduates. All right, so let's go over to SAS. So here is the solution to our first problem. So I create a data step. Input cups at this double at sign has SAS stay on one line, on the same line, while it's reading in data. So data lines, semicolon, let it know that data is coming up. And then here's just, you can have, and this is just showing, you can have as many spaces as you want in between your bits of data. So I've got 4 or 5, all right. So there's all the data and semicolon to signify the end of the data. Now I'm going to do a proc means, data equals problem 6, better be problem 6, 1, right? Mean, I want the mean, I want the standard deviation, and I want the confidence limits for the mean, and I'm going to tell it to run. So highlight all that, click our little running guy here, and there you go. The mean is 4.25, standard deviation is 2.659, lower confidence limit 2.02, upper limit 6.47. There you go. Easy as can be. All right, let's go back here to our second problem. So this one, let's scroll up a little bit, says a clinical trial is conducted to compare an experimental medication to placebo to reduce the symptoms of arthritis. 400 participants are enrolled in the study and randomized to receive either experimental medication or placebo. The primary outcome is self-reported reduction of symptoms. We have 200 who received experimental medication, 84 report reduction of symptoms, and 42 participants out of 200 report reductions of symptoms in the placebo. So what we need to do here is generate a 95% confidence interval for the difference in proportions of participants reporting reduction of symptoms between the two groups, estimate the relative risk for reduction, estimate the odds ratio for reduction in symptoms between the groups, and generate a 95% confidence interval for the relative risk. So let's go back to SAS. Now let's go down here. So problem 6.2, I'm going to input 3 things: if they had the treatment, if they improved, and how many fell into that group. So treatment is a character variable because it has things like experimental and old, so I have a $sign after it. Improved, also, yes or no, so also has a $sign, also character variable. And weight's numeric. So there's my input statement, semicolon. Data lines, semicolon, and then there's the data. There were 84 in the experimental group that showed improvement, which meant there were 116 that did not, right? Because minus 200. There were 42 in the old placebo group that didn't, and 158, or 42 that showed improvement, 158 did not. Now, here's an interesting thing about the difference in proportions. That is the risk difference, right? Because all the risk difference is the difference in proportions who had whatever event was. So we do proc freq, data equals prob 6.2, my data set up here, tables, treatment times improved, / risk diff, and relative risk, rel risk, because we wanted to get that relative risk data as well. So semicolon, weight, don't forget our weight statement, and I called it weight, but you could have called it anything, number, people, semicolon, and run. So let's see what that does for us. And here you see that 58 is the proportion that were not improved for the treatment group, and 79, the proportion that were not improved for the old or placebo group. 42 was the percent that were improved for that group, and 21 were the percent that were improved for the placebo. So let's look first at our risk, so the risk would be 58 and 79, and the risk difference is negative 0.21, and the confidence limits for that are from minus 0.2987 to minus 0.1213. Then if we look down here, it's going to give us the exact same values, but if we looked at it, instead of looking at the risk for not being improved, the risk, if you want to call that, for improvement. And here it's just the other way around. It's 0.21 is the difference, and our confidence limit is from 0.1213 to 0.2987. So there's where you get your confidence limits for the difference in proportions. Then we scroll down here, we get our odds ratio of 0.3671. If you wanted the confidence limits for that, it wasn't asked for in the problem, but if you wanted it, there they are, 0.2361 to 0.57. And relative risk for column 1, 0.73, for column 2, 2.0. So I found this the easier one to interpret. It basically says that your risk or probability of improvement is double if you're in the experimental group than in the control group. And the confidence limits are from 1.46 to 2.73. You can see that 1.0 does not fall in there at all. 1 is what the relative risk would be if your probability of improved symptoms was exactly equal in the two groups. So there are your confidence limits for relative risk, your odds ratio, and your difference in proportions, and your confidence limits for the difference in proportions. All right, let's see if we can take a third problem. Now, here's our third problem. It says, a crossover trial is conducted to compare an experimental treatment for migraine headache to a currently available medication. You have 49 patients enrolled in the study. Each one receives both treatments. And we have the mean difference between the experimental and currently available is 12.8 minutes, with a standard deviation of 5.6 minutes. Construct a 95% confidence interval for the mean difference in times between the experimental and currently available medication. Well, this you really didn't need SAS for. You could do it with a calculator, but since we're on to using SAS, what the heck. So over here, we've got data prob 6.3. Still, let's compute the standard error of the mean difference. 1.96, because we want the 5% probability level. What's the standard error? It's the standard deviation divided by the square root of the number of people, which was 49. I thought I'd put in this, would you? So the lower confidence limit is minus 12.8, which is your mean minus the standard error of the mean difference. The upper confidence limit is minus 0.28 plus the standard error of the mean difference. And then let's just compute this and print it. So do proc print. Little secret there, actually SAS by default uses the last created data set if you don't give it a data statement. That's actually kind of bad practice, but I just put in there to let you know that that's what happens. So run this, and this tells me the standard error of the mean difference, I don't really care, is 1.566, but it tells me the lower confidence limit is 14.368, and the upper is negative 11.232. So there you go. That's how you do all of those things in the homework with SAS.